I'm just gonna get the finish line, just waving at you, just waving.
Savage.
Playing crabs? Let me show you how to do some tricks in the pool. Because I'm going to D over T this and speed right through it. I don't got time for you guys.
Yo, why you gotta exert your force on me, man?
What's the big deal? Why are you destructively interfering with our game?
Because you guys are terrible at this. You have to learn to take some constructive criticism. Let me show you some pool tricks and show you how it's done.
Alright, let's see what you got.
Let's go right now. Watch and learn.
Alright, let's see it. Oh, that trick shot? That was so basic. While you were taking the shot, I actually drew out the schematic right here to explain exactly how you did it, and it's so basic. So you had two balls, right? Ball 1 and ball 2. This is an elastic collision because friction is negligible, which means that kinetic energy is conserved, and it also means that momentum is conserved. So the initial momentum is equal to the final momentum. The initial momentum is only constituted by ball 1, and the final momentum is only constituted by ball 2, because these are the only balls that are moving respectively at those times, right? So M1v1 is equal to M2v2. The mass of both of these is the same, so you can say that the velocity of ball 1 initially is equal to the velocity of ball 2 at the end. What ends up happening is that ball 1 hits ball 2, it comes to a stop, it transfers all of its momentum to ball 2, and ball 2 moves forward. And that's how the trick works.
I got it.
Sure you do.
Let me show you an even better pool trick shot.
Alright, that was a pretty good trick, but I bet you I can explain how it worked though. So basically this is how it went down. This is very similar to Newton's cradle. What happened is that you had all of these balls that had the same masses. This initial ball came in and it had a velocity, while these balls were stationary. Momentum was conserved, right? So what happened was that this ball transferred its momentum to this ball, which transferred it to this ball, which transferred it to this ball, and so on. What ended up happening was, since momentum is conserved, P initial is equal to P final, and the ball mass of this is equal to the mass of this. The last ball ended up moving with the same velocity as the velocity of the initial ball. Momentum was conserved, and that's why one ball moved at the end.
Uno momentum, por favor. Watch me one up you.
Literally.
That was pretty good.
Alright, Mr. Shades, let me shine some light on what just happened. It's basically the same idea as earlier, which we can connect to Newton's cradle. So what happens is there's two masses, which means they have a total mass of mt1 moving with the velocity of v1. At the end, there's going to be two balls moving away with v2, which in this scenario will be the same as v1 because their masses are same.
Yo, I got a crab trick up my sleeve too. Watch me turn the stored potential into motion. Alright, you guys might think that's a case of magic, but actually it can be explained using some laws of physics. So basically what happened was, before, you had this ball right here, which had a momentum in this direction because its velocity was occurring in this direction. This ball right here was stationary. So what ended up happening was there was an elastic collision between the two balls, meaning that their momentum was conserved and that energy was conserved. And one ball ended up going in this direction, and one ball ended up going in this direction, which is why this momentum occurs in this direction, and this momentum right here occurs in this direction. So if you add the individual, the final momentum vectors together, they form a 90-degree angle, and they actually add up to the initial momentum vector. So P initial is equal to PF1 plus PF2. P initial is equal to PF, which means that momentum is conserved, and that's how the trick worked. No magic involved.
Ooh, he got you there, man.
Alright, I'm not gonna lie, the physics behind those shots was pretty interesting. But before, I used to think of physics as being icky, as in phys-ix, but now I think physics is sick, as in phys-6. Now I gotta accelerate out of here.
Later.